Master. So suppose if I want to go for next page and see that space is not sufficient to explain, what should I do?
Minimize this size.
Okay.
This one.
Can minimize this. Okay. Or otherwise, once I explain, I have to remove and I have to explain.
Blank page you will insert.
Where? Here. Here.
That. You can add that blank page.
Good morning, students. My name is Prasad. I'm a chemistry faculty in RJR Academy. So today we are going to discuss yesterday's Neet paper, Neet question paper, answers of the Neet question paper. Let us start. So you can see on the board question paper code, that is T5. Today we are going to discuss T5 code. T5 code. Let us take the 51 question. It is given from the 12th class P block elements, that is 16th group. So 51, question number 51, question number 51. Question number 51, given from 12th class P block elements. In that 16th group. In 12th class you have 4 P block, 15, 16, 17 and 18. You see that statement 1 the boiling point of the following hydrides of group 16 elements increases in the order. They gave the order H2O less than H2S less than H2SE less than H2TE. But if it is very clear, in 16th group element we have a tabular column of hydrides. In that they clearly mentioned the order of boiling points. H2O is greater than H2TE and H2SE and H2S. Remember, the expected order is this, but this is correct order. In general, boiling point increases with increase in molecular mass. But if you see here, water has abnormally high boiling point, that we know very well, 373 Kelvin. The reason for that, it has hydrogen bonds. If you see the other hydrides, as usual, so the molecular mass of this is more, that is the reason why it has higher boiling point. Next this. So the first statement is wrong. And the second statement, what is that second statement? The boiling point of these hydrides increase with increase in molecular mass, or we can say molar mass. Molar mass. So that is also wrong. In general, boiling points increase with molar mass, but in this case, boiling point of these hydrides increase with increase in molar mass. That is wrong. So both statement 1 and statement 2 are incorrect. So 51 answer is first. You see that this time they gave majority of the statement questions. So keep this in your mind for the students who are going to repeat the examination for next academic year. Then let us take 52, question number 52. So it was given from the ionic equilibrium. Ionic equilibrium. In ionic equilibrium, they gave this question from buffer solutions. From buffer solutions. And we know the formula of the buffer solution. To calculate the pH of the buffer of acid buffer, pKa plus log salt concentration divided by acid concentration. This is for acid buffers. You know what is concentration? Concentration is molarity into volume. That will give number of millimoles. If it is milliliter, then you will get millimoles. They gave already pKa. pKa they gave 4.57 and 50 ml each of 0.1 m sodium acetate and 0.01 m acetic acid. You see that this is 4.57. So 4.57 is the pKa they gave already. Log salt concentration is 50 into 0.1. So it can be written as 10 power minus 1 divided by 50 into 10 power minus 2. And the concentration of salt is 50 into 10 power minus 1 divided by 100. Because in overall volume, what is its concentration? Similarly, 50 into 10 power minus 2 divided by 100, 100 will go to the numerator, 100 will cancel. 50 will cancel. Then if you take the log 10 power minus 2 into numerator, it will become log 10. Because log 10 power minus 2 becomes log 2. And that is 10 power 1 minus 1. 10 power minus 1 into 10 power 2 is log 10. Log 10 is 1. So 4.57 plus 1 is equal to 5.57. This is the pH value. Let us go to the paper 1. You see that fourth option is the correct option. Fourth option is the correct option. For 52, question number 52, option 4 is correct. Next, coming to the 53. go to the 53. Question number 53. Let us see the question. So they gave assertion and reasoning type question. This is given from 17th group. Again, it's a 12th class P block elements. P block elements. 12th class. And P block they gave from 17th group. It's a direct textbook question. So in textbook, if you see that in textbook there was one box. There they mentioned this question. ICL is more reactive than I2. It's correct. Why it is correct? Because I and Cl bond is weaker than II bond. This is also correct. So it means that both assertion and reason are correct, and reason is the correct explanation for A. Reason is the correct explanation of A. So for 53 question, option 4 is the right answer. Option 4 is the correct one. Then coming to the 54th question, it is purely memory based question. It is also given from the inorganic chemistry, which is from S block elements. We know that S block elements belong to 11th class. So this question is given from the 11th class S block elements. And let us read the question carefully. It's purely memory based question. They gave A, B, C, D. It's a matching type question. They gave A, B, C, D. A is lithium, B is sodium, and C is potassium hydroxide, D is cesium. So advantage for the matching type questions, if you know at least 2 answers correct, then you can able to answer this question. That is majority of the times it happens. Sometimes it will be difficult even if you know the 2 answers, unless until you know the 3 answers. Okay, let us discuss. Lithium is used in electrochemical cells. Sodium is used as a coolant in fast, that means liquid sodium is used as a coolant in fast breeder reactors. These are nuclear reactors. And we know very well KOH is a absorber of carbon dioxide. It absorbs carbon dioxide. And we have discussed already this while discussing the estimation of carbon in organic chemistry, that is in 11th class. Then cesium we know very well, and potassium, rubidium, cesium are highly electropositive. They readily give electrons, hence they are used in photoelectric cells. So the correct option for 54 is 3. That is A is 3. A is 2. B is 3. C is 1. And D is 4. So for 54, option is 3. Third option is correct. It is from textbook only, and it is given in the uses of the lithium, sodium. It is given in the S block elements, uses of those. Next, coming to the another question, that is 55. Even 55 is also another statement type question. The questions, if they gave in statement wise, it consumes more time. Okay, choose the correct statement. This is also given from the inorganic chemistry. Inorganic chemistry, 55. It is given from inorganic chemistry. P block elements, P block elements, P block elements of 11th class. This is given from 11th class. In 11th class, we have 13th and 14th groups. 13th and 14th groups. They gave this question from the 14th. They gave this question from 14th group. Let us go to the question. Diamond is covalent and graphite. See, choose the correct statement. That means out of 4, 3 of them are wrong. Only 1 is correct. Diamond is covalent and graphite is ionic. Wrong. Both are covalent. We have already studied in while discussing the solid state in covalent solids. While discussing the covalent solids, we have discussed that in solid state. Diamond, graphite, silicon carbide, silicon dioxide, they are all covalent solids. So that is wrong. Diamond is sp3 hybridized, correct, because it has tetrahedrally arranged carbon atoms. Graphite is sp2 hybridized, that is also correct. In graphite, each carbon is sp2 hybridized and they are arranged in the hexagonal rings, and the rings are joined together to form layers. Got it? So that is the right option. It's the right statement, correct statement. Both diamond and graphite are used as a dry lubricant. That is wrong. Only graphite is used as a dry lubricant, not diamond. Diamond and graphite have two-dimensional network. Wrong. Diamond has two-dimensional network, whereas graphite has three-dimensional network. Next, coming to the which statement regarding the polymer. So answer for 55 is 2. So 55 right option is 2. 55 right option is 2. Next, let us move to the next question. That is 56 question. It is also again a statement question. Which statement regarding polymers is not correct? So this is given from the polymers. This is given from the polymers. You see that? That is 57th question. 57th question given from polymers. So in polymers, we have classification of polymers. In that, we have elastomers, fibers, thermosetting polymers, and thermoplastic polymers. So regarding those 4 types of polymers, they gave this question. Fibers possess high tensile strength. It's correct. They are asking incorrect statement. It's a direct statement is given in the textbook. Thermoplastic polymers are capable of repeatedly softening or hardening on heating and cooling respectively. It's correct. It's correct. You see, thermoplastic polymers are recyclable, like for example polythene, polyvinyl chloride. They're recyclable. We can recycle them number of times. So we can, if you heat them, they melt, and if you cool them, they become solid. Thermosetting polymers are reusable. This is wrong. Thermosetting polymers are not reusable. They cannot be remolded again and again. Best example is bakelite, used for making cooker handles, electric switches. So that is wrong statement. So 56 option is 56 option is 3. And elastomers have polymers chains held together by weak intermolecular forces. That is also correct. So 56, it's not 57. Just a minute. It is 56. 56 option is 3. It's a director. It is also a memory based question. Memory based question. Coming to the 57, the incorrect statement regarding the chirality. This is given from the organic chemistry. 57, given from organic chemistry. Organic chemistry from haloalkanes. From haloalkanes and arenes. Haloalkanes and arenes. This question is based on basically SN1 and SN2 mechanism. While SN1, SN2 mechanism is taking place, if the compound involved in SN1, SN2 mechanism has chirality, then which statement is correct? They are asking that. Very interesting question. The product obtained by SN2 reaction of haloalkanes having chirality at the reactive site shows inversion of configuration. Yes, in SN2 mechanism, only inversion of configuration takes place, whereas in SN1 both retention and inversion takes place. So the statement is correct statement, no doubt about that. Coming to the second one, enantiomers are the superimposable mirror images on each other. It's a direct definition question. If you know the definition, you can answer it. Enantiomers we can define as non-superimposable mirror images. Non-superimposable mirror images, but they gave superimposable mirror images. So this is wrong statement. So answer is this. Let us see the remaining statements also. A racemic mixture shows zero optical rotation. Exactly correct. Racemic mixture is an equimolar mixture of G and L forms. So dextrorotatory and levorotatory. So their angles are equal and opposite. So it will become optically inactive. Then an SN1 reaction yields 1:1 mixture of both enantiomers. That is also, it is not 100% statement correct, but majority as per the textbook it is 50-50. They gave in the textbook, that's so it's correct. But in SN1 mechanism, what happened if you take chiral center? So generally inverted product is slightly more than the retention product. But as per the textbook, it's correct, so that there is no ambiguity in the question. So it is 100% correct. So statement 2 is wrong. So for 57, 2 is the right option. 2 is the right option. Now let us go to the next question, that is 58 question. It is given from the complex compounds, coordination compounds. 58, this is given from coordination compounds. Coordination, very important chapter for Neet examination. Generally they will ask 2 questions. Coordination compounds. As usual, we are seeing the question on this coordination compounds. So they ask this question on the nomenclature. This is a little interesting question, because if the compound has both cation and anion are complexes, it's a rare question. In textbook they gave only one example in the textbook, so that it's not a regular expected question. But this kind of question is given in the textbook. You see that cation is complex, anion is also complex. Then what will be the, you see that Ag H2O taken twice, this is cation. Generally we write cation first followed by anion. This is cation So complex, both complexes are cation and anion, and or we can say complex compound has both cation and anion as complex. The other one is AgCN taken twice. This is the question. So naturally, what happened? It forms anion. So it will be AgCN taken two times minus, and it will be AgH2O taken two times plus. So as usual, while naming the compound, either it is a simple compound or a complex compound, we should name the cation first, followed by anion, like sodium chloride, magnesium bromide. In the same way, we should name it. And you see that the oxidation state of silver here is +1. Here also it is +1. That is very important. You have to identify that. Then that is the case. What will be the answer? We'll check it. You see that diaqua silver 2, wrong. Already told oxidation state of silver should be 1. So the diaqua silver 2, dicyanide argentate 2, that is wrong, because silver oxidation state is 2 here, that is not possible. Then coming to the second one, dicyanide. No, first we have to name the cation. So cation is AgH2O taken twice, that is also wrong. Then diaqua silver 1, that is correct. Dicyanide argentate 1. So option 3 is right one for 58. So 58, 3 is the right option. 3 is the right option. So very important, we should do. So we have done the first page. We have done from 51 to 58. Please check the details. Next we'll go to the page number 2. Let us start with 59th question. 59. It is given from the thermodynamics. This is also another important chapter for Neet examination. Thermodynamics. Thermodynamics. They give pressure volume graph. It is directly given from the textbook. Pressure volume. So this is the graph they gave. This is the graph they gave. You see that work done is equal to minus P delta V. Minus P delta V. So volume difference is more, work done will be more. So these two have confusion. No chance of this, because isothermal temperature is constant. So temperature constant means there will be a relation between pressure and volume. So pressure increases, volume does not remain constant. That is wrong. Here pressure and volume are changing, but volume range is very, very less. That is the reason why it is not a correct answer. In case of isothermal reversible compression or expression, then you will get the same graph like this. Like this, you will get the graph. You will get that graph. So work done will be maximum in reversible isothermal expansion or compression. Okay. So the right option is, for 51, right option is 1. Next, coming to the 60th question. This is given from the surface chemistry. Yes, surface chemistry. It is given from the surface chemistry. Definitely you will get one question from the surface chemistry. Yeah, this is given from the surface chemistry. Statement 1 they gave. We know that Hardy-Schulz law, according to, good morning Raja. So according to Hardy-Schulz law, for negative colloids, charge on the cation should be more for more coagulation. For cationic, that means for positive colloids, charge on the anion should be high for high coagulating power. Let us take the statement 1 in the coagulation of negative sol, that is 60th question. Negative sol is coagulated by a positive ion. They gave 3 positive ions, Al3 plus. Just now I told, according to the Hardy-School's law, charge on the cation is more, it has more coagulating power. So they gave another one is Ba2 plus, another one they gave Na plus. No doubt this is the correct statement. Whereas for positive sol, anion should have more negative charge. This is the correct order as per the Hardy-School's law, but they gave reverse. In textbook, in the examination, they gave like this. This is Cl minus, and they gave Na2SO4, and this is 2 minus. They gave this order. This is absolutely wrong. Absolutely wrong. This has -3, this has -2. So statement 2 is wrong. Statement 2 is wrong. Statement 1 is correct. So correct option is statement 1 is correct, but statement 2 is wrong. Option 2. So 20th question, sorry, 60th question, option 2 is the right one. Option 2 is the right one. Next, coming to the 61, this is from organic again. Question number 61. This is from organic chemistry. It is given from hydrocarbons chapter of 11th class. Hydrocarbons, 11th class. That is benzene. In hydrocarbons, they gave benzene. Aromaticity. The concept is aromaticity. That is the concept. On this concept, they ask the question. We'll go back. We'll check the. You see that which compound among us the following is not an aromatic? What are the conditions required for aromaticity? Number 1, there should be a planar ring structure. Yes, all are having planar ring structure. Planar ring structure means all the carbon atoms should be on the same plane. Second one is there should be a conjugation. Conjugation means alternate double bonds. Yes, it has alternate double bonds. Even this has alternate double bonds. Next thing is there must be a delocalization of pi electrons. Here there is a delocalization of pi electron, number 1, because these electrons can shift here and these electrons can shift here. So all are sp2 carbons. Delocalization is possible. Here also delocalization is possible. Here delocalization is not possible because it is a cycloheptatriene. Cycloheptatriene. You see that? Here this is sp3 carbon, so that these electrons cannot migrate. So here there is no delocalization. Delocalization doesn't take place in this. That is the reason why it is not aromatic. And another condition for aromatic is there must be, according to Huckel's rule, there must be a 4n plus 2 pi electrons. You see that it has 4n plus 2 pi electrons. It has 6 pi electrons. It has 2 pi electrons. It has 6 pi electrons, but there is no complete delocalization. And there is a 6 pi electrons. This is negative charge. These electrons can involve in the resonance. So that first, second, and third, fourth are correct. Third one is not an aromatic. So Option is 3 for 61. So 61, 3 is the right option. Right option. This is given from the aromatic, that is aromaticity, and from organic chemistry. Let us go to the next question. Even next question 62 matching. This is also given from the organic chemistry. It's quite interesting. Product formed cyanohydrin, acetal, Skips base, oxime, reaction of carbonyl compound with NH4OH, RNH2, alcohol, HCl. So this is a very important concept which we discussed in the aldehydes and ketones. This is again question number mm, question number 62. Yeah. Question number 62 given from organic chemistry. Organic chemistry. And this is given from 12th, that is aldehydes, comma, ketones and carboxylic acids. From this they gave this question. Very interesting question. So first option they gave cyanohydrin. Second they gave acetal. Third one they gave Skips base. Fourth one they gave oxime. You see that C double bond O, this is carbonyl compound, maybe aldehyde or ketone. So if both R's are there, we can say ketone. If it is H, aldehyde. When it is treated with the HCN, this is a nucleophilic addition reaction. You see that these pi electrons are shifted onto that, so it will become minus and it will become plus. So this is nucleophile, it is adding on to the nucleophilic center. So you get cyanohydrin. So HCN will give cyanohydrin. Then acetal. You see that when aldehydes and ketones are treated with, especially aldehydes when treated with alcohols, ROH, then what happened? You see that R or H, you can say OR, OH. So this is actually hemiacetal. Hemiacetal is further converted into acetal. You see that OR, and this will become OR by reacting with one more alcohol. So with alcohols we'll get acetal. With amines we'll get Skips base. You see that C double bond O, R, or we can say H, or we can take R. When treated with amine, so what happened? This is nucleophilic addition followed by elimination. You'll get Skips base. C double bond N, or one side R and one side R or H. This is Skips base. So with amines we'll get Skips base. Then oxime. When aldehydes or ketones, when treated with hydroxylamine, then what happened? Water is eliminated. Nucleophilic addition followed by elimination. This is what you call oxime. We already discussed oximes exhibit syn anti-isomerism. Oximes exhibit syn anti-isomerism. So the right option for this is this 3. 3 is the right option. We'll go to the question once again. You see that cyanohydrin HCl, A is 4, correct. Acetal alcohol 3 is correct. Skips base is 2, that is correct. Oxide 1 is correct. So this is about organic chemistry question. Next we'll go to the 63. It is given from electrochemistry. It is given from electrochemistry. Let us see this question. At 298 Kelvin, the standard electrode potentials of copper electrode, zinc electrode, iron electrode, silver electrode are 0.34, minus 0.76, minus 0.44 volts, and 0.80 volts. So here there is an important question is very important. Electrode whose reduction potential is less can displace the electrode whose reduction potential is more from the salt solution. Or I can tell in a simple way, instead of electrode we can write metal also. Metal whose reduction potential is less can displace the electrode or the metal whose reduction potential is more. Let us go to the question. So highest is silver. Its reduction potential is more. Lowest is zinc. After that we can see that iron. Iron and zinc can displace copper and silver. See that iron, in first reaction, iron displaces the copper, correct? Second case, zinc can displace iron, yes, because zinc is having less standard reduction potential, that is minus 0.76 compared to iron. Next one, silver has more standard reduction potential compared to copper. Silver has 0.80 and copper has 0.34. So silver cannot displace copper, but copper can displace silver. So option is 3. They are asking on the basis of standard electrode potential, predict which of the following reaction cannot occur. So third one is the right option. That doesn't take place. So 63 is given from third one, and it is given from electrochemistry. It is given from electrochemistry. Clear, students? Understood? It is given from electrochemistry. So right option is 3. Next 64, they asked this question from surface chemistry. 64 they asked from surface chemistry. So already we discussed one question from the surface chemistry. This is the second question. That means they gave 2 questions from the surface chemistry. One already we discussed, that is coagulating power. That is given from colloids. This is given from catalysis. Let us go to the question. This is also again a statement question. The incorrect statement regarding enzymes is, first question, like chemical catalysts, enzymes reduce the activation energy of bioprocess. It is 100% correct. They gave characteristics of enzyme catalysis in our textbook. If you are thorough with those points, You can easily answer this question. So second one, that is correct statement. They are asking incorrect statement. Enzymes are polysaccharides. That is wrong. Enzymes are generally proteins. They are not polysaccharides. They are not carbohydrates. So that is wrong statement. And enzymes are very specific for a particular reaction and substrate. 100% correct. We know that an enzyme can catalyze only one reaction. It cannot catalyze more than one reaction. That is the reason why you can say it is highly specific. Next, coming to the fourth one, enzymes are biocatalysts. Correct. Correct. So 64 answer is second option. So second option is the incorrect statement. So this is about 64. So we have completed third page. So then we are going to third page. We have completed second page. We are going to third page. 65. Question number 65. It is given from the organic chemistry. 65. Organic chemistry, and from amines of 12th class. Amines, 12th class. 12th class. We know that first statement 1, primary aliphatic amines react with nitrous acid. This is what we call diazotization to give unstable diazonium salts. It's 100% correct. Why aliphatic diazonium salts are unstable? Because they don't have resonance. Due to lack of resonance, aliphatic diazonium salts are highly unstable. Hence, they give unstable diazonium salts. So statement 1 is correct only. Statement 1 is 100% correct. Let us take the statement 2. Primary aromatic amines react with HNO2 to form diazonium salts which are stable even above 300 K. No doubt, primary aromatic amines like aniline. Aniline is an example of primary aromatic amine which react with nitrous acid to produce diazonium salt. But remember, very, very important, it is stable between 0 to 5 degrees centigrade. 0 to 5 degrees centigrade. So that at 300 degrees centigrade, they are not stable. So statement 2 is wrong. Statement 2 is wrong. Statement 2 is wrong. So what is right option here? Statement 1 is correct, but statement 2 is wrong. So 65 option is 2. 65 option is 2. Next, let us go to the 67. 6. It is given from the states of matter. States of matter. Yes, definitely there will be one question from states of matter, atomic structure. Yes. Which are not correct mathematical equations for Dalton's law of partial pressures? We know Dalton's law of partial pressures. This is states of matter, belongs to 11th class. 11th class. 11th class. You see that according to Dalton's law of partial pressure, P total is equal to P1 plus P2 plus P3. Sum of the partial pressures of individual gases. So P1 can be written as N1 RT by V. Yes, they gave the correct one. P2 can be partial pressure of gas 2 can be written as N2 RT by V. Correct only. So first option is correct. Second, what is another one? The partial pressure. Partial pressure. PI means partial pressure. Partial pressure is equal to partial pressure of a gas is equal to total pressure into mole fraction. So second one is also correct. Xi they gave mole fraction, that is chi. Chi is given, that is mole fraction. Third one they gave Pi is equal to Pi is equal to mole fraction into pressure of a gas individual, or pressure of the gas in a pure state. This is actually Raoult's law. Raoult's law. Raoult's law. So this is not a mathematical expression of Dalton's law of partial pressure. And already I told P is equal to P1 plus P2, P3. That is also correct. So third option is the incorrect mathematical expression. So questions little tricky, but overall questions are the well-known questions within the textbook, within the limit of the textbook they gave. Next, we'll go to the next question. What is next question? Match, again they gave match. Most of the questions I have seen in this paper are statement type questions and as well as the matching type questions. Let us go to the next question. 66. Match the list and 1 with list 2. This is given from hydrogen and its compounds. Hydrogen and its compound, question number 67. Question number 67 they gave from hydrogen and its compounds. Hydrogen and its compounds. Hydrogen and its compounds. See, in hydrogen's compounds we have different types of hydrates. Hydrogen combines with metals and non-metals to form different types of hydrates. That is the question. Based on that they gave question. Magnesium hydride. It is an ionic hydride. It is also called salt-like hydride. So A option is 4. Germanium hydrides. Carbon, silicon, germanium, they belong to 14th group. Their hydrides are electron precise hydrides. So B option is 2. B option is 2. B option, sorry, B option is 1. Sorry, B option is 1. B option is 1. X. B2 is 6. You know that diborane. Diborane is an electron deficient compound. So it's an electron deficient. So C is 2. HF electron precise. Sorry, electron rich. Electron rich. Why? HF is an electron rich. So it has octet, fluorine has octet, and at the same time it has lone pair of electrons, hence it is called electron rich hydride. Electron rich hydride. Rich hydride. Rich hydride. So for 67, right option is 4. Right option is 4. Of course, this is a well-known question. Generally, we emphasize that. And so the covalent hydrates are classified into 3 types: electron deficient, electron rich, electron precise. On that, they asked question. It's a normal question only. Neat point of view, it's normal question. Coming to the 68 question. Yeah, it is given from again aldehydes and ketones. Already we have discussed one question from aldehyde and ketone. Again they gave the aldehydes and ketones. Aldehydes and ketones. This is from 12th class syllabus. 12th class syllabus regarding the boiling points. Very important. Very important. The boiling points of aldehydes and ketones are higher than hydrocarbons of comparable molecular masses. 100% correct. Because weak molecular association in aldehydes and ketones due to dipole-dipole interactions. Correct. Statement 1 is correct. It is a direct textbook statement. The boiling points of aldehydes and ketones are lower than alcohols of similar molecular mass due to the absence of hydrogen bond. This is also correct. Alcohols have higher boiling points than aldehydes and ketones with comparable molecular masses because alcohols have hydrogen bonds. So statement 1 is correct and statement 2 is also correct. So 68 right option is both statement 1 and statement 2 are correct. Statement 1 and statement 2 are correct. So fourth option is the right option. 69. So in organic, generally they give chapter-wise questions. Generally, we can expect the conversions in the organic chemistry, but this time they didn't give that kind of questions. Generally, they confine to a particular chapter. We have seen that aromaticity that is given in the benzene, and we have seen aldehydes and ketones question that is given strictly from the aldehydes and ketones. And another question we have seen diazotization that is strictly limited to the amines. So generally in this question paper, we didn't find the conversions. Okay. Next, coming to the, that is generally students expect such kind of conversion. 69th question. It is also an interesting question. It is given from the, again, S block elements. S block elements, that is 11th class question in organic chemistry. 11th block, S block elements, 11th class. Already we discussed one question, that is application based question, that is sorry, the memory based question, used based question, uses they asked. Now they are asking application oriented question. You see the oxidation number of potassium in KO2 is +4. This is wrong. They are asking identify the incorrect statement, that is itself incorrect statement. You see that potassium belongs to alkali metals. Remember, alkali metals always exhibit +1 oxidation state. If it is a +1, O2 should be -1. So potassium should not have +4 oxidation state. And this is a potassium superoxide. You know that in superoxides, oxygen oxidation state is -1/2. So overall O2 oxidation state is -1. So that is a wrong statement. So 69, first one is the right option. And we'll see the next one. What are they? Ionization enthalpy of alkali metals decrease. Alkali metals decreases from top to bottom in a group, correct? Lithium is the strongest reducing agent among alkali metals. That is also correct. Alkali metals react with water to form their hydroxides. Yes. Sodium reacts with water to give sodium hydroxide. Potassium reacts with water to give potassium hydroxide. It is 100% correct. Coming to the 70th question. This is given from the chemical bonding. Chemical bonding. Chemical bonding. So this is given from the chemical bonding. Area of the chemical bonding is molecular orbital theory. Molecular orbital theory. Which among us the following is incorrect statement? C2 molecule has 4 electrons in its 2 degenerate pi molecular orbitals. 2 degenerate pi molecular orbitals. Degenerate means same energy. You see that C2 atomic number of electrons is equal to 12. What is sigma 1s2, sigma star 1s2? This is the order of filling of electrons in a bonding and antibonding occurs. Sigma 2s2, sigma star 2s2. So 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Still 4 electrons are left. They will enter pi 2px is equal to pi 2py. These are all degenerate orbitals. Degenerate orbitals means orbitals having same energy. This has 2 electrons, this has 2 electrons. Overall, there are 4 electrons. This is correct. Go to the next one. Go to the next one. H2 plus H2 plus ion has one electron. Correct only. That is also correct. You see that hydrogen H2 has two electrons. H2 plus means it has only one electron. That is also correct. Coming to the next one. O2 plus ion is diamagnetic. You know, peroxides are paramagnetic in nature. O2, sorry, it's O2 plus, not peroxide. O2 plus is, they said diamagnetic. No, it's paramagnetic. We'll see that. O2 plus. O2 plus has 15 electrons. We know for 14 electrons, that is N2. N2 has 14 electrons. It is diamagnetic. Diamagnetic. So since it has one electron extra, which is present in the anti-bonding orbital, which is unpaired electron, so it is paramagnetic. It is para, not dia. Paramagnetic, not diamagnetic. So it is wrong statement. So 74th is the third is the wrong option. 73rd is the wrong option. Next, coming to the, of course, the bond order of O2 plus O2, correct, O2 is O2 plus is 2.5, O2 minus is 1.5, O2 2 minus is 1, correct one. Next, this is an interesting question. This is a little bit tough question for the students or just average or above average. For intelligent students, it's okay. Only problem for the average, above average students. Above average students also they feel difficult this because it looks bit difficult. So this is the equation they gave. Yeah, 2H2O. 2H2O. Now they are asking question, how much amount of calcium carbonate required to react with 50 ml of 0.5 m HCl. This is they gave only 95%, not 100%. First we calculate assuming that it's 100%. For that simple one is V1 M1 by N1 is equal to V2 M2 by N2. So, sir, volume is not given. We have to find out mass, very simple. V into V1 into. Molarity we are writing weight by molar mass into 1000 by V. That is V1. This V1 cancel. And then N1. N1 is only 1 mole. N2 is 2 moles. Is equal to 50 into molarity, that is 0.5, will give millimoles, divided by number of moles is 2. We have to find out this weight, assuming that 100% pure. So W we have to find out, divided by molecular mass of calcium carbonate is 100 into 1000 by, this is equal to N is equal to 1. 0 cancel, 0 cancel, is equal to 50 into 0.5 is 5 into 5, that is 25. 25 divided by 2, that is millimoles. This is equal to this. Then we want W. So this if you divide, you will get 12.5. Then W is equal to 12.5 divided by 10, that is equal to 1.25. So interestingly, this option is also given in the question. If it is 100%, we need this, but they gave only 95%. So the weight of CaCO3 95% required is equal to 1.25 into 100 divided by 95, that is equal to 1.32 grams. So option 1. This is little tricky for the students. First we have to assume as a 100% calculate, but it is 90%, we have to calculate. So this is little tricky. So I have doubt in that how many students did well in this. So 71 we discussed. 71. Yeah. 70. There is 70. This 71. Yeah. This is 71. 71 answer is 1. Next go to the next page, that is 72. Remember in this is given from basic concepts of chemistry. This is given from basic concepts of chemistry. First chapter of the 11th class. First chapter of the 11th class. Okay, then go to the next page. This is from organic chemistry, general organic chemistry. First chapter, organic chemistry. This is commonly asking question. Geldahl's method is used to estimate the nitrogen, but there is a limitation with Geldahl's process. In Geldahl's process, nitrogen cannot be estimated when nitrogen is present in the ring or involved in the present in the ring or involved in the N double bond N, that is azo, or present in the NO2. So first one, ring is nitrogen is involved in the ring. Third one, there is a N double bond N. Fourth one, NO2 is there. So right option is 2. Right option, aniline is the right option. So Geldahl's method for the estimation of nitrogen can be used to estimate the amount of nitrogen in which one of the following compounds, that is aniline. You know that benzene has NH2 group is nothing but aniline. Okay. Next, let us move to the next question, 73. Yeah, it is given from the structure of atom. So this is a little tricky question. I think it is a tough question for the, in my opinion, it's a tough question for the average and above average students. It is good question for the intelligent students. Identify the, again it is a statement type question. Identify the incorrect statement from the following. Number 1, all the 5 d orbitals have shapes similar the respective 3d orbitals. It's a correct statement. So 3d orbitals or 4d orbitals or 5d orbitals, they have the same shapes, that is double dumbbell. All are same. Next, second question, in an atom, all the 5 d orbitals are equal in energy in free state. It's correct. Whereas in the magnetic field or electric field, they split into 2 groups, T2G and EG, that is dxy, dyz, dzx, dx square, y square and dz square. Next, the shapes of the dxy, dyz and dzx orbitals are similar to each other. That is correct. And the dx square, y square and dz square are similar to each other. That is wrong. You know that dx square y square shape is like this. and dz square shape is like this. So they are not same. So they are not similar. So this is a wrong statement. Then all the 5D orbitals are different in size when compared to the respective 4D because energy variation. 5D has more energy than 3D. Definitely they have difference in sizes. Little tricky question. So you should be very careful while answering this kind of questions. Answer is 3. Next, coming to the next question. Go to the next question. 74. It is given from kinetics, chemical kinetics, chemical kinetics. Chemical kinetics. You see that they gave one graph. There is no variation. You are getting a straight line means there is no variation. So we already discussed in the class in RJR. You see that they gave y and z in the graph. See that y and x they gave y and x. Then they gave very interesting question. I'm not sure how many students answered this question. Let us take zero order. The y and x axis for zero and first order reactions respectively. So for zero order reaction and first order reaction, what is y and x they are asking. We already know that for zero order reaction, rate of reaction does not depend on the concentration of the reactants. So for zero order, rate and concentration. If zero order y is rate and x is concentration, then there is no change in the rate of reaction. Rate does not change with the concentration in zero order reaction because it does not depend on the concentration. It depends only on the surface area of the catalyst. Next, coming to the for first order reaction, T half and concentration. So second option, very interesting question. So second option is the right option. So for this, second option is the right option. Second option is the right option. Then coming to the next question, 75. Yeah, among the following, which one will have maximum lone pair electron repulsion? If you use logic, you can easily understand. The number of lone pairs will increase, then repulsion between the lone pairs increase. So you see that IF5, how many lone pairs are there in the IF5? It is question number 75. IF5, how will you find out? Very simple, number of valence electrons 7 plus 5 divided by 2, that is 12 divided by 2, that is equal to 6. So 6 electron pairs, it is forming 5 bonds. So bond pairs are 5, lone pairs are 1. So it has only one lone pair. Coming to the next compound they gave SF4. You see sulfur has 6 electrons, 6 plus 4 divided by 2, 10 by 2, that is equal to 5. And there are 4 bonds, so bond pairs are 4, lone pair is equal to 1. Next, coming to the another compound, that is XCF4. You see that XCF2, XCF2, 8 plus 2 divided by 2, that is equal to 10 divided by 2, that is equal to 5. Since it is forming 2 bonds, bond pairs are 2 only, lone pairs are 3. So it has more number of lone pairs, so repulsion will be more. Then another example they give ClF3. ClF3. See that chlorine, ClF3. Chlorine has 7 electrons, 7 plus 3 divided by 2, 10. 10 by 2 is 5. It has 3 bond pairs 3, lone pairs 1. So lone pairs 2. It has 2, it has 3, it has 1, and it has 1. So it has maximum repulsion. So that option 3 is the right one for 75. 75. So it is given from the, again it is given from the 17th group elements. 17th plus 18th. Or we can say that chemical bonding. Anyone we can. But it's an inorganic chemistry only. Chemical bonding. Chemical bonding. Chemical bonding, or we can say inorganic chemistry. Clear? Next, coming to the next question. It is given from the organic. 76 they given from physical chemistry, that is solutions. 76 given from the physical chemistry, that is solutions, 12th class. They gave question on molality. Molality is equal to weight by molar mass into 1000 by V W solvent in grams. Then they gave question here, 1 molar solution that contains 0.5 moles of a solute, there is 500 grams of solvent, 100 ml of the solvent, 1000 grams of the solvent, 500 ml of the solvent. 1 molar solution. You see that? Molality is 1. 1 molar means molality is 1. Weight by molar mass they give 0.5 moles into 1000 by, we want to find out the weight of solvent. Then weight of solvent is equal to 0.5 into 1000, that is equal to 500 grams. So option 1 is correct for 76. Okay, clear now? Next, go to the next one. 77. It is again organic chemistry. 77, that is from organic chemistry, and that too they confine to carboxylic acids. Carboxylic acids. This is most of the times we discussed, but so some students may confuse based on the options. RMgX they gave plus CO2 they gave gives rise to Y they gave. Y on hydrolysis they gave RCOH. No doubt, Grignard reagents when treated with carbon dioxide followed by hydrolysis will get carboxylic acids. Then he is asking what is Y. You see that carbon dioxide can be written like this. One of the pi bonds are shifted to the oxygen, so it will get minus plus. You know, Grignard reagent splits into R minus MgX plus. So R adds on plus, MgX adds on plus, so that R C double bond O MgX. So this is the option. Instead of giving like that, they gave like this. So students should understand, should not confuse. That is the option they gave, fourth option. So fourth option. So 77 answer is fourth option. Next, 78. It is bit difficult for normal students, especially the students who are afraid of the numericals. It's not a numerical actually. It is a logical thinking question. It is given from electrochemistry. Already we have seen one question from electrochemistry. Again they gave electrochemistry question. Electrochemistry. In same section they gave section A, they gave electrochemistry question, and again they gave electrochemistry question in section. You see that it's quite interesting question. They gave MnO4 minus plus 8 plus H plus 5 electrons gives rise to Mn2 plus 4 H2O. He gave E0 Mn2 plus bar MnO4 minus. It's a reduction potential. And again they gave half O2 plus 2H plus 2 electrons gives rise to H2O. It is also again a reduction potential. If they give reduction potentials, if you set up a cell, what will be the formula? What will be the formula? E0 cell is equal to E0 cathode minus E0 anode. Minus E0 anode. So if you see that, which one acts as a cathode and which one acts as an anode? Very simple. The standard electrode potential, which is less between two, always acts as an anode, and which is more acts as a cathode. So the first one is minus, that is less, so it acts as an anode, and the other one acts as a cathode. So what will be the E0 cell here? E0 cell is equal to E0 cathode. E0 cathode, how much they gave? E0 cathode is plus 1.223 plus 1.223 1.223 minus of minus 1.5. So minus into minus plus. So plus we are getting 2 point something we are going to get. So plus we are getting means oxygen will be released. Oxygen will be released. So what is the question they are asking? Will the permanganate ion MnO4 liberates O2 from the water in the presence of acid? Yes, it liberates because E0 value is plus 2.733. So 78 option is 2. So 78 option is 2. Clear? Next, coming to the next one. Yeah. Again, the statements given below, two statements are given. Statement 1. This is given from the organic. This is given from the organic. That is 79. Given from the organic chemistry. Given from the organic chemistry. Acidic strength of mono-substituted phenols. They give phenol. Organic chemistry. This time organic chemistry questions are little interesting. They didn't give the conversions. They confined to a particular chapter only. This is given from the phenols. You see that acidic strength of mono-substituted nitrophenol is higher than phenol because of the electron withdrawing nitro group. That is correct. So phenol is just OH group present on the benzene ring. Orthonitrophenol or paranitrophenol or metanitrophenol are the mono-substituted. It may be substituted here or here or here. Definitely it is more acidic than phenol. Next statement, first statement is correct. Orthonitrophenol, metanitrophenol, paranitrophenol will have the same acidic strength as they have one NO2 group, nitro group attached to the phenolic ring. This is wrong. We know that Para-nitrophenol is more acidic than orthonitrophenol than metanitrophenol. This is the order that we discussed in the class. So statement 1 is correct, but statement 2 is wrong. 79 is 2. So 79 option is 2. Coming to the, yeah, so 79 over. So next we'll move to the next paragraph, next page. That is question number 80. Question number 80. Yeah, this is very simple question. Commonly they are asking. IUPAC name of the element with atomic number 119. For 1 we use un, 11 un. For 9 we use n. So it is unanium. So we use this for 9, this for 1, this for 1. So option 4. 4 is the right option. This is from periodic classification. So they gave one question from periodic classification. They gave one question from other atomic structure. They gave one question from chemical bonding. An 81 question. This is from inorganic chemistry. Inorganic. And inorganic chemistry. 11th class P block. 11th P block, that is 13th group elements. 13th group elements regarding the boron, especially diborane. This is the diborane structure. This is diborane structure. These are bridge bonds or banana bonds. Regarding this, they asked question. There are 4 terminal BH bonds or 2 center 2 electron bonds, and 2 center 2 electron bond, there are 2 electrons. So like that there are 4 terminal bonds. The statement 1 is correct. The 4 terminal hydrogen atoms and the 2 boron, 4 hydrogen atoms and 2 boron atoms are in one plane, that is also correct. Both the boron atoms are sp2 hybridized, that is wrong. This is sp3, this is also sp3. This is wrong. So answer is 3. There are 2 3-center 2 electron bonds, that is correct. So 81 answer is 3. Next, coming to the '82. This is again a statement question. Majority they gave statement questions. Given below there are 2 statements. One is assertion, the other one is reason. In a particular point defect, this is given from solid state. Given from solid state. In solid state, they gave from the defects. You know, there are 3 types of point defects: stoichiometric, non-stoichiometric, and impurity defects. So they gave this question on the stoichiometric defects. A particular point defect, an ionic solid is electrically neutral even if few of the cations are missing from its unit cell. Yes, because whenever the cations are missing, anions are also missing, so that the statement is correct. In an ionic solid, Frankel defect arises due to the dislocation of the cation from its lattice side to the interstitial side, maintaining overall electrical neutrality. This is also correct. But remember, the assertion is different, reason is different. So reason is not a correct explanation for assertion. So both are correct, but reason is not the correct explanation for assertion. So answer is 4th one. 82, 4th one. 1 minute. Sorry, by mistake. So this is 1. So both A and R correct, but R is not a correct explanation of E. 4th option is both A and R correct and R is the correct. If that is wrong, that is wrong. Next, let us move to the 83rd question. 83rd question. This is given from the matching. It is given from the chemistry in everyday life. I have already seen one question given from the polymers. The other question they gave chemistry in everyday life. Everyday life. This is a matching question. Matching question. Matching question. You see that antacid, antacid, antihistamine. There's a bit confusion, antacids and antihistamines. In my point of view, it's a little bit tough question. Analgesics, antimicrobials. So in this, they don't have any doubt because salvarsan, morphine. Morphine is nothing but it is a narcotic drug. It is a painkiller. Analgesic means it's a painkiller. So that is easily students can recognize. And salvarsan is antimicrobial. That is also they can easily. But the problem is antacids and antihistamines. There they generally they should be very careful. So you see that antacid is celdane, sorry, cimetidine. Antihistamine is celadine, and that is first option. First option. Then analgesic is morphine, that is second one. C second. D antimicrobial is one. So for 83, for 83, for 83, option is one. This is little bit tough. Little bit tough. So there will be a confusion. That is the reason why I am saying that it's a tough question, bit tough question. And again, 84 question is from the inorganic, sorry, organic. 84 given from organic. Organic. So this is a very simple question. You see that phenol NaNO2 HCl CuCl2. You won't get phenol when treated with NaNO2. You won't get chlorobenzene. Phenol does not convert into diazonium salt. Phenol when treated with NaNO2 and HCl, you won't get the diazonium salt. Aniline when treated with NaNO2 and HCl, you will get diazonium salt. That reaction does not possible. Coming to the second one, benzene when treated with HCl, that is not also possible. That reaction is not possible. Aniline when treated with HCl eating, you will get aniline is a base, HCl is an acid. You will get salt, ammonia, that is anilinium chloride. It does not give chloride. But benzene when treated with chlorine in the presence of anhydrous FeCl3, it's a direct question. So option is 4. So this is my point of view. It is easy question. Easy question. Then gadolinium 85. This is given from the 85, given from D and F block elements. D and F block elements. D and F block elements. This is also a bit difficult question. Gadolinium GD. You know, electronic configuration is 4F7, 5D1, 6S2. See, once it loses all 3 electrons, that means third ionization potential is low. It gets 7 electrons and it will become half filled. Half filled orbitals are more stable due to exchange energies. That is the question they ask here. High exchange enthalpy, yes, that is correct. So 85 option is 1. But student should get the correct answer. So if they strike in their mind, they can easily answer. Otherwise, it will become difficult. If they know the electronic configuration, definitely it will strike. Otherwise, it will become a difficult. Next, coming to the section B. Section B. That is 86 question. 86 question. It is given from the organic. It is based on the aldol condensation. Very interesting question. They gave acetone when treated with 2-pentanone. So 2-pentanone. This is 2-pentanone. Then he is asking Which of the following compound does not form? Does not form. Treating with NaOH. See, there are 4 possible products we are going to get. There are 4 possible products. One is this reacts with this reacts with this. So this reacts with this. You see that acetone, one of the hydrogens, alpha hydrogens are transferred to another acetone molecule. This is one possibility. So what happened? This hydrogen is shifted so that once it is shifted, it will become OH. This is attached to this CH2, CO, CH3, and there is a CH3. Of course, you see that once OH is removed and hydrogen is removed, you'll get a double bond here. So finally, you are going to get this compound CH3, C double bond CH3, CH, CO, CH3. You see that compound is possible or not? Yet, which case? Which case? Yeah, this is the case. That is the case. Fourth option, that is possible. That is possible. Fourth option, that is possible. Then another possibility, we'll see that. Another. So this is possible. Fourth option is possible. Suppose this hydrogen is shifted to here, then what will you get? CH3, C double bond O. So this is attached to this CH2. This is attached to this carbon. See, this CH3 will go down, and here we'll get a double bond. CH, CH2, CH2, CH3. So this is nothing but double bond O. 1, 1, 2, 3, 4, double bond CH3, and this. This is also possible. Yeah, this is. Yeah, this is CH3 double bond O CH3 CH3. That is also possible. That is also possible. Yes. So this is not possible. Why means CH3 single bond CH2. We are taking acetone. We are taking acetone. So that is not possible. So whenever you take acetone, and at the same time we are taking CH3, CO, both are nearby. So it is not possible to get CH3, CH2, C double bond O. C double bond O. So this is wrong. So the option is first option. 86 is, so they have to work out. Students need some extra time to work out. So if they have any chance, they can eliminate it. They can leave it. And question 87. This is again given from atomic structure. 2 questions given from the atomic structure. This is a simple formula. The student have an idea, they can easily do that. See, energy is equal to energy of hydrogen atom into Z square by N square. So for helium plus they gave 105.8 picometer. 108.5 picometer. 108.5 picometer is equal to E naught. We don't know E naught. Z is helium means 4. 2 square is 4. Second orbit means 4. Then they are asking you to calculate what is the radius of the third orbit of lithium 2 plus. Lithium 2 plus, this we have to calculate E naught. So lithium means 3 square is 9. 9 by third orbit is 9. Okay. If you divide both of them, what will you get? 108.5 divided by x is equal to E naught into 4 divided by 4. E naught into 9 divided by 9. So 9 9 cancel, 4 4 cancel, E naught cancel, x is equal to 108.5 picometer. Same answer we are going to get. So that is oh 1 minute 87 1 minute. Second and third orbit of lithium. The radius of the second Bohr's orbit. So this second orbit, third orbit, lithium 3 square 9. Square 9. Second orbit of the helium. Okay, lithium 2 plus 158.7 picometer. This is E naught into Z square by N square. Z is helium, square is 4. Second orbit 2 square. Lithium. So this will check it later. This one. Third Bohr's orbit. Second lithium. Z square by N. We'll see it. Next. Next we'll check it. That we'll see that later. 88. So 88 is given from solid state. 88 they given from the solid state. You see, direct formula you can apply here. D is equal to Z into M divided by A cube into Avogadro's number. So D they gave, we want to find out M. D into A cube into NA divided by Z into Z is equal to M. D they gave, there is 8.92 into it is 3.6 into 3.6 into 3.6 into 10 power minus 8 whole power 3, that is 24 minus 24 into Avogadro's number 6 into 10 power 23 divided by Z Z is equal to face centered cubic Z is equal to 4, that is equal to M. If you simplify that, you will get 63.1. So the option is fourth option. Fourth option. So for 88, option is 4, fourth option. Then coming to the 89, 89, 89, 89. So given below are two statements. Again, it's a organic chemistry. 89th question is from organic. Direct question. Organic chemistry. Direct question. Organic chemistry. Organic chemistry. See, in Lucas test, primary, secondary, and tertiary alcohols are distinguished on the basis of their reactivity with concentrated anhydrous zinc chloride, known as Lucas reagent. Correct. So Lucas reagent is used to differentiate primary, secondary, and tertiary alcohols. Statement 2. Primary alcohols are more reactive and immediately produce turbidity at room temperature on reaction with Lucas reagent. This statement is wrong. Tertiary alcohols are more reactive than secondary and primary. So statement 2 is wrong, statement 1 is correct. So statement 1 is correct, but statement 2 is wrong. So 89 option 2 is correct. 89 option 2 is correct. Next, coming to the next question, that is from organic. This is given from the states of matter. 90 they gave from the states of matter. Already we have seen one question given in the states of matter regarding Dalton's law of atomic theory. Now they gave again one more question. States of matter. You see that they gave the question based on the PV is equal to nRT. So we have to find out P. P is equal to nRT by V. N is number of moles. This is a simple question and easy question. So 64 grams of oxygen means 64 divided by 32, that is equal to 2 moles. 2 into 0.083 into temperature is 27 means 300 Kelvin divided by volume they gave 10 liters. That will give, if you simplify that, you will get 4.9. So 4.9 is the answer for this. If you simplify this, you will get 4.9. 4.9 bar. 4.9 bar. Because they give R value in bar. Okay. So option is 3. Next, coming to the question number 91. 91. It's an interesting question. Commonly asking question, that is on bosonolysis. 91. Question number 91 is based on the bosonolysis. Bosonolysis. It is again organic chemistry, straight question. So, what is the question they asked? You see that compound X on treatment with O3 followed by zinc and water gives formaldehyde and 2-methyl propanol as a product. The compound X is. So we are getting formaldehyde and 2-methyl propanol. First you have to check that. Formaldehyde. This is formaldehyde and 2-methyl propanol. This is the compound we are getting. 2-methyl propanol. See, simply remove this and write the compound. You will get CH2 double bond CH, CH3, CH3. What do you call this name? What is the impact name is this? 1, 2, 3, 4. 3-methyl but 1 ene. So 2-methyl but 1 ene. So 2-methyl but 1-ene. 2-methyl but 1-ene or 3-methyl butene, 1 minute. 1 minute. So 1 minute. Yeah, sorry, 3-methyl but 1-ene. So option is fourth option. So fourth option is 3-methyl but 1-ene. So fourth option 3-methyl but 1-ene. Next another question. Next another question. 92. Yeah, it is given again from 92. This is again given from D block elements. In D block elements, we have two important compounds, potassium dichromate and potassium permanganate, K2Cr2O7 and KMnO4. So on this they ask question. You see KMnO4 acts as an oxidizing agent in acid medium. In acid medium, +7 oxidation state changes to +2. In neutral medium or fairly alkaline medium, it converts into MnO2. So its +4 oxidation state is +7 oxidation state. Whereas in basic medium, KMnO4 is converted into K2MnO4. So oxidation state changed from +7 to +6. See, iodine is converted into iodate in fairly alkaline or neutral medium. Iodide iodide is converted into, here iodide is converted into I2. So hence iodide is converted into iodate, means it's a neutral or fairly alkaline. So oxidation state is changing from +7 to +4. So fourth option, 92, fourth option is the right option. Fourth option is the right option. Next, let us go to the next question. That is, this is the question given from the kinetics. 90, 94, 93 or 94. This is given 93 question. 93 question. It is given from the kinetics. See, initially concentration of reactant is 0.1 m. After 5 minutes, the concentration, this is initial concentration, final concentration is 0.01 m. After 5 minutes. Then they are asking rate constant. They are asking us to calculate. It's a first order reaction. First order reaction means rate is equal to K into concentration of reactant power 1. You know what is rate? Change in concentration. See, 0.1 minus 0.00 0.001. Okay, then 10 minus 1 is 9, 1, sorry, 0. So it is, rate is 0.99 divided by 5 is equal to K into initial concentration is 10 power minus 1 whole power 1. If you take this into this side, 0.99 divided by so 0.5, this will give 0.19. So option is first option. So 93 question option is 1. 93 question option is 1. Next, let us go to the 94 question. Yeah, 94 question. 94 question is given from 94 question is given from electrochemistry. So in section B, you have a chance to leave 5 questions without attempting. So this is actually given on the Nernst equation. We know Nernst equation. Already they gave 2 questions in electrochemistry. This is third question. E is equal to E naught cell minus 0.059 by N log oxidant divided by reductant. Oxidant divided by reductant. You see that E naught value they gave wrong. 10.5 is the wrong. Actually, it should be 1.5. That is the reason why they are going to add marks for this. Actually, they gave 10.5. That is the reason why you won't get the proper answer. They could have given 1.05 minus 0.059 divided by number of electrons involved into log. So they gave nickel under silver. Nickel concentration they gave 10 power minus 3 divided by, this is 10 power minus 3 whole square. It is 10 power minus 6. If you take it to the numerator, 1.05 minus of 0.059 by 2 log 3. Log 3 is 3. So if they could have given 1.05, the answer will be 2. Answer will be 2. But answer will be 2, but this is wrong. So probably they are going to add the marks for this. We have to wait and see what they are going to do that for this question. Next, 95. This is an organic question. This is also a direct question. This is only, you can see the conversion question. That is also a very simple question. Okay. This is benzene and CH2, sorry, CN they gave. Here CN they gave. Once it is treated with lithium aluminum hydride, what happened? This undergoes reduction. Cyanides undergo reduction to give primary amines CH2, NH2. This are treated with nitrous acid. What happened? Diazotization takes place, but it is a aliphatic diazonium salt. You will get N2Cl, which is highly unstable. Immediately it converts into alcohol by losing nitrogen gas. So answer will be this. So we'll check the answer. So answer will be third option. So answer will be 3 for this. Answer will be 3 for this. Next, last one. 96. So it's a matching type. It is given from the metallurgy. It is a very simple question. If you remember the ores of the metals, you can easily answer this. Hematite is Fe2O3, A is 3. A is 3 given in two options 1 and 2. Then magnetite Fe3O4, that is 1. So both options B is also correct. Then calamine ZnCO3, that is second option. So 96, 1 is the right option. Then 97, this is given from the coordination compounds. Already I told you coordination compounds, they gave two questions. One is already given, that is nomenclature, coordination compounds. They gave nomenclature question, coordination compounds. In that you see that, see, order of energy absorbed, which is responsible for the color of the complex. You see that as strong ligands increases, the number of strong ligands or strong field ligands increases, energy absorbed will be more. You see that nickel, see option C, ethylene diamine are 3, so that it absorbs more energy. And A, you see that ethylene diamine ligands are 2, then it absorbs more energy than B. So right option will be A, C greater than A greater than B. So 97 is second option. Then 98 is also a easy question because they gave this on the nomenclature. It's a simple question. You see that numbering, 98 question, organic chemistry, that is general organic chemistry. They gave the question like this. This is Br, and they gave OH here, and they gave methyl here, and Cl here. Remember, this is functional. Always give the top layer to the functional groups while giving the numbering. So we should numbering from the right to left. 1, 2, 3, 4, 5, 6. If you give numbering from left to right, you will get 1, 2, 3, 4. 4 is getting wrong. So third is correct one. So we should give numbering from right to left. So it will be, then we should follow the alphabetical order. Methyl, hexane, 3O. So right option is 4. Right option is 4. Then 99th question. We know that this is given in the equilibrium. Equilibrium already we have seen one question. Then another question they gave. Equilibrium. One question they gave on the buffer solution. The other question they gave on the equilibrium constant. Kc is equal to products concentration divided by reactants concentration. O3 whole square divided by O2 whole power 3. Am I right? You know that Kc is equal to, they gave O2 concentration, they gave O2 concentration as 0.04. Kc they gave as 3. You see that Kc is equal to Kc is equal to 3 into 10 to the power of minus 5, 59. O2 concentration they gave as 0.040. It can be written as 4 into 10 power minus 2. Then 3 into 10 power minus 59 is equal to O3. O3 concentration we have to find out. O3 whole square divided by O2 they gave, that is 4 into 10 power minus 2 whole power 3. So you take this into this side, it will be 3 into 4 into 4 into 4 into 10 power minus 6 into 10 power minus 59. So 4 4s are 16, 16 4s are 64, 64 into 3 into 10 power minus 65. (192) into 10 power minus 65. So this can be written as 19.2 into 10 to the power of minus 64 is equal to O3 concentration square. We want O3. So under root of 19.2 into 10 to the power of minus 34 is equal to O3 concentration. So root, forget about root. 10 power minus 34 will become 64 will become 10 power minus 32. So check the answer. So fourth option. Fourth option has 10 power minus 32. 10 power minus 32. So 10 power minus 32. So the fourth option is the right option. Fourth option is the right option. Then coming to the last question, that is 100, they gave from the environmental chemistry. 100th question they gave environmental chemistry. Environmental chemistry. So this bit difficult in my opinion because you have to remember the entire chapter. The pollution due to oxides of sulfur gets enhanced due to the presence of particulate matter. It's a direct textbook sentence. Ozone, because what happened? Ozone decomposes to give oxygen that converts sulfur into sulfur dioxide or sulfur dioxide into sulfur trioxide. It enhances. And the other one is hydrogen peroxide also gives oxygen. So whereas hydrocarbon doesn't help, ozone and hydrogen peroxide, since they release oxygen, they help to convert sulfur dioxide into sulfur trioxide. Once sulfur trioxide is increased, it is converted into acid rain. Acid rain. So this is about the entire Neet 2022 paper. By and large, my opinion, for intelligent students, it's good paper, but average and above average paper, bit bit tough, bit tough, particularly some areas, and it's lengthy also. Lengthy also. There are some questions which are straightforward questions, nomenclature and matching questions. They are easy, but statement questions, unless until the student is thorough, they cannot do all the questions. Okay. Thank you.